When we think of stars, we probably imagine tiny shiny items in the night sky. At least, this is how we see them from down here on the planet. But stars are something else entirely. In fact, one of the biggest stars, Betelgeuse, happens to be much larger than our Sun. For years, this star has baffled scientists, but recently, something more unsettling has been happening with Betelgeuse, making scientists and other well-informed folks very, very concerned. Join us in this video as we explore the terrific news about Betelgeuse, its impending destruction as expected by the James Webb Space Telescope, and how this new development will affect our galaxy and our lives right here on the planet. As explained by physicist Michio Kaku, Betelgeuse is a cosmic wonder, a large star that has intrigued cosmologists for so long. A Greek astronomer named Tony was the first to discover it. This star is so huge that it can be seen in the night sky from Earth, particularly during winter. If you're into constellations, you've probably seen or heard of this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and so far one of the brightest stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay constant. Instead, it fluctuates. This fluctuation is one of the unique properties of this star. But it isn't the only one. Let's look at some of Betelgeuse's specific properties. Most of the stars you see in the night sky are actually far from Earth. The nearest star is 4.2 light-years away from Earth. If you don't understand how the term light-years explains distance, picture it this way. Consider moving at the speed of light for a whole year. It's been proven that light can cover a distance of 186,000 miles per second. Therefore, the distance light can cover in a year is equal to 1 light-year. If you do the math, you'll have billions of miles. So, when we say the closest star is 4.2 light-years away, it means it is billions of miles away from Earth. But guess what? Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is located approximately 600 light-years away from Earth. So, if you were to travel to it at the speed of light, it would still take 600 years. We can't move that fast. Not even our fastest spacecraft can. But this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, that's because of its other qualities like size and brightness. Betelgeuse is about 500 times larger than our Sun. Its radius is believed to be about 1,000 times that of the Sun. It's so big that it appears as a disk in space when using sophisticated telescopes, while other stars appear as little points of light. This appearance is suspected to be an effect of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse measures about 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equal to 2 times 10 superscript 3 kg. Scientists cannot determine the exact mass of Betelgeuse because there are no other planetary bodies orbiting around it to compare with, and of course we can't measure it directly from here on the planet. But it's proven that this star is at least 12 times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is 16,000 times brighter than our Sun. No wonder it was nicknamed a red giant. However, the brightness of Betelgeuse doesn't stay constant. It fluctuates. This fluctuation is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, but when it contracts, it dims. This process can last for 10 to 100 days or even more. One unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these regions is far stronger than at the normal surface, but the downside is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has lots of these spots compared to our Sun explains why it is cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and very numerous. To give you an idea, the spots on Betelgeuse can be twice as large as the Earth. Betelgeuse also boasts a magnetic field that is 1,000 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on the surface of Betelgeuse appear to be in loops or arcs. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature contributes to the low energy emitted by the star and its dim red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish about 2 million years ago, just like our sun. Over the years, the color started changing to orange-red, and then about 2,000 years ago, it slowly started becoming the red star we know today. This fact has made scientists believe that the star is aging. Betelgeuse emits as much as 7,500 times more energy than the sun. It would have been a fierce rival to Earth's sun if it weren't so far away and in its prime. The fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite remarkable. Our sun is only 8.3 light-minutes away from Earth. That's why it's so powerful. If Betelgeuse were just slightly closer, we would also be able to see it during the daytime. But if it were to replace the sun, it would swallow up or displace the Earth and the other 4 planets near it because of its enormous size. Furthermore, even if it could match it, it emits more radiation than our sun. Betelgeuse, also known as Betelgeuse, is a supergiant star located in the constellation Orion, approximately 600 light-years away from Earth. Its immense size is one of its most striking features. It is about 500 times larger than our sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This colossal size allows Betelgeuse to appear as a distinct disk rather than a point of light when observed through powerful telescopes, unlike most other stars. Despite its enormous size, Betelgeuse is not the most massive star. It ranges in mass from about 12 to 19 times that of our sun. This variability in mass estimation is due to the challenges in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nevertheless, even at its lower estimated mass, Betelgeuse remains a significant stellar entity. The brightness of Betelgeuse is another noteworthy characteristic. It varies irregularly over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be 16,000 times brighter than our sun. This variability is attributed to its pulsations, periodic expansions, and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct reddish-orange hue characteristic of red giant stars nearing the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution, where it has exhausted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It exhibits dark magnetic spots on its surface, which are significantly larger and more numerous than those found on our sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper within the star to its surface, contributing to cooler spots on the star's surface. Betelgeuse's history and cultural significance also make it a prominent celestial object. Known since ancient times, Betelgeuse has been observed and documented by various civilizations throughout history. Its visibility in the night sky, particularly during winter in the northern hemisphere, has made it a prominent feature in constellations and mythology. In recent years, Betelgeuse has garnered increased scientific attention due to its dimming episodes, which began around late 2019 and continued into early 2021. During these periods, the star's brightness dropped to unprecedented levels, sparking speculation among astronomers about its imminent fate. Betelgeuse, also known by its formal name Betelgeuse, is a prominent star in the constellation Orion, located approximately 600 light-years away from Earth. It stands out not only due to its position as one of the brightest stars in the night sky, but also because of its immense size and variability. This supergiant star has captivated astronomers and skywatchers alike for centuries, offering insights into stellar evolution, cosmic distances, and the dynamic nature of the universe. Betelgeuse is classified as a red supergiant star, which means it is in the late stages of its stellar evolution. In terms of size, Betelgeuse dwarfs our own Sun. Its radius is estimated to be about 500 times larger than that of the Sun, which means it would extend far beyond the orbit of Mars if placed at the center of our solar system. Despite its immense size, Betelgeuse is not the most massive star. Its mass ranges from approximately 12 to 19 times that of the Sun, depending on various estimates and calculations. One of Betelgeuse's most intriguing features is its variability in brightness. Unlike our Sun, which maintains a relatively stable luminosity over time, Betelgeuse undergoes irregular fluctuations in its brightness. These fluctuations are attributed to pulsations within the star caused by changes in its internal processes. At its brightest, Betelgeuse can shine 16,000 times brighter than our Sun, but during dimming episodes, its brightness can drop significantly. The star's variability has been a subject of intense study among astronomers. Observations over the centuries have documented these changes, providing valuable data on the star's life cycle and physical characteristics. Understanding the mechanisms behind Betelgeuse's brightness variability is crucial for unraveling the complexities of stellar evolution and the behavior of massive stars. Betelgeuse has a surface temperature of approximately 3,500 Kelvin. This relatively low temperature for a star of its size contributes to its distinct reddish or orange coloration. The star's spectrum, when analyzed through spectroscopy, reveals absorption lines that indicate the presence of various elements in its atmosphere. These elements include hydrogen, helium, and heavier elements produced through nuclear fusion processes occurring deep within the star. Betelgeuse exhibits pronounced magnetic activity on its surface, characterized by the presence of dark magnetic spots. These spots are regions where the star's magnetic field is significantly stronger than in surrounding areas. They interfere with the normal convection processes that transport heat from the star's interior to its surface, resulting in cooler regions on the star's surface. The study of these magnetic features provides insights into stellar magnetism and its influence on the dynamics of supergiant stars. Betelgeuse has been known and observed by civilizations for millennia. Ancient astronomers from various cultures, including the Greeks, Egyptians, and Chinese, documented its position and observed its brightness variation. In ancient Arabic astronomy, Betelgeuse's name, derived from the Arabic phrase Yad al-Jah, meaning the hand of Orion, reflects its prominence in the constellation. The star's visibility and variability have inspired numerous myths and cultural references throughout history. In Greek mythology, Orion the hunter, with Betelgeuse marking his shoulder, is a prominent figure. The star's changing brightness was often interpreted as a sign of strength or mood, influencing stories and beliefs across different cultures. In addition to its cultural significance, Betelgeuse has been a focal point of scientific study for astronomers. Observations using telescopes and spectroscopic instruments have provided detailed data on the star's physical properties, including its size, mass, temperature, and chemical composition. These observations have contributed to our understanding of stellar evolution and the life cycles of massive stars. Recent observations of Betelgeuse have sparked renewed interest and speculation among astronomers. In late 2019 and early 2020, the star exhibited unprecedented dimming episodes, causing its brightness to decrease significantly. These dimming events caught the attention of the astronomical community, leading to hypotheses and theories about the underlying causes. One of the most discussed hypotheses is the possibility of Betelgeuse undergoing a supernova event in the relatively near future. Supernovae are cataclysmic explosions that occur when massive stars exhaust their nuclear fuel and undergo gravitational collapse. If Betelgeuse were to undergo a supernova, it would release an immense amount of energy and become one of the brightest objects in the night sky, visible even during daylight hours. The potential supernova of Betelgeuse has captured public imagination and scientific interest due to its proximity and visibility. Astronomers continue to monitor the star closely using telescopes and space-based observatories to gather data on its behavior and evolution. Betelgeuse's status as a red supergiant provides valuable insights into the later stages of stellar evolution. These stages involve the fusion of heavier elements in the star's core, leading to the production of elements like carbon, oxygen, and iron. The study of Betelgeuse and similar stars helps astronomers understand how stars evolve and enrich the universe with chemical elements necessary for the formation of planets and life. Studying Betelgeuse also contributes to our understanding of galactic dynamics and the role of massive stars in shaping galaxies. Supergiant stars like Betelgeuse play a crucial role in the chemical enrichment of the interstellar medium, seeding future generations of stars and planetary systems with heavy elements. The variability and complex behavior of Betelgeuse challenge astrophysical models and theories. Understanding the mechanisms behind its pulsations and brightness fluctuations requires sophisticated simulations and observational techniques. By testing and refining these models, astronomers can improve our understanding of stellar processes and their broader implications for galactic and cosmic evolution. Future observations of Betelgeuse will continue to play a crucial role in advancing our understanding of stellar evolution and supernova dynamics. Long-term monitoring campaigns using ground-based observatories and space telescopes will provide ongoing data on the star's variability, magnetic activity, and potential for a supernova event. Advancements in observational technology, such as next-generation telescopes and adaptive optics systems, will enhance our ability to study Betelgeuse and other distant stars in unprecedented detail. These technologies will enable astronomers to probe deeper into the mysteries of stellar interiors and atmospheric dynamics. Combining observations across different wavelengths of light, from radio waves to gamma rays, will provide a comprehensive view of Betelgeuse's physical processes and interactions with its environment. Multi-wavelength studies are essential for unraveling the complex interactions between magnetic fields, stellar winds, and the surrounding interstellar medium. Betelgeuse remains a cornerstone of astronomical research and discovery, offering valuable insights into the life cycles of massive stars, galactic dynamics, and the origins of chemical elements in the universe. Its variability, historical significance, and potential for a supernova event make it a compelling subject for ongoing and future studies. By continuing to explore and observe Betelgeuse, astronomers will deepen our understanding of stellar evolution and the dynamic processes that shape the cosmos.